Good day to all. Today we'll be dealing about some problems in circuit theorems and networks. All the problems in this slide are gonna be based on the Charles Alexander book, which is the fundamentals of electric circuit. And these problems are some of the very basic problems which you need to understand and apply the formulas or the theorems used here for doing the problems of basic electronic circuits properly. So let's begin. So this is being done as a part of the digital assignment 2, which is given in my college, which is the VIT University, under the guidance of my teacher, Dr. Jagannath. So let's go. So here's our problem 1. So the problem 1 states that which of the circuits is planar? For the planar circuit, redraw the circuit without any crossing branches. So here are the two circuits. So basically planar circuit, as the name itself suggests, is nothing but a simple planar circuit. That is, it must not have any kinds of crossings which are there in this circuit. Like for example, here the branches get crossed. So such a circuit cannot be called a planar circuit, which is a non-planar circuit. Now our task is to convert this particular this particular non-planar circuit into a planar one. So let's see how we are gonna go about it. So here's the way how we're gonna do it. So see, the first circuit simply can be redrawn as shown. For example, you can just see it like explicitly it's given. So there is nothing which we gonna do. So there is nothing much of effort which we need to put in this problem. So it's a very basic problem and anyone can do it easily. And now even for the second circuit we would do the same way. That is, we are first the 4 ohm resistor, that is the one over here. Yeah, the 4 ohm resistor is over here is connected straight through this and to this terminal. That's it for the second part of the problem. Easy as it seems. Yeah. So we'll go to the next problem. Our next problem is also gonna be dealing with the planar circuits, and in this problem we need to identify which of the circuits are planar. That is, some circuits may not be put up in a planar form at all. So for such circuits we need to determine how to do this. So yes, let's go. And yeah, here's the solution. The first circuit is a planar circuit and is redrawn in this way, but the second one is not planar. Anyhow you try to solve that, you cannot solve it. This can never be made into a planar circuit because, as you can see, you can try it out by trial and error, or just by looking at the circuit you can tell that whether it can be made into planar or not. And yeah, now let's go to the next problem. Our next problem involves quite a lot of numerical to go about it, but once with appropriate practice anyone could crack this problem easily. So nothing but here the problem is that we need to find V0 in the circuit by using the mesh analysis. So here we take three currents, I1, I2 and I3, flowing through the branches. So here's how we are gonna go about the problem. So we draw the circuit in this way. So through this loop there is current I1, and through this loop there is current capital I2, and this I1, I2, I3, please don't get confused with that. This is a 1 with a capital symbol. So this current we are gonna use in our mesh analysis. So here we write for the loop 1, that is using I1, we are gonna write the circuit equations. So what we get is simply this equation: 12 is equal to 10I1 minus 6I2. That is, by looking at this circuit, 12 is equal to 10I1 minus 6I2. Then on solving the second circuit we get this. So now we are gonna put down the same thing in a vectorial form. So while putting down it as a vector form, we are gonna do something like this. That is, we are first gonna simplify this circuit. So on simplifying, that is dividing it by 2, what we get is 6 is equal to 5i1 minus 3i2, and same thing dividing by 2, we get something as minus 5 is equal to minus 3i1 plus 4i2. So we are gonna write this in the form of matrices. So here is the way how we are gonna represent the equation in a matrix form. So this is basically nothing but the matrix form of the equation. Now on using Kramer's rule, that is, we are finding delta. Delta is nothing but this determinant of this matrix. So we found the determinant of this matrix, which is nothing but 11. Now delta 1. Delta 1 is nothing but simply replacing the first column of the determinant delta by the constant matrix over here, that is 6 and minus 5. So we are going to replace it and find its determinant, which is nothing but 9. Now for delta 2, same way we are going to replace the second row with the constant matrix over here and 6 and minus 5, and we are going to expand, we get minus 7. So I1, our current I1 is nothing but delta 1 by delta. So basically what we are using here is Kramer's rule. If you wouldn't understand Kramer's rule, there are many links to learn Kramer's rule in YouTube and many other sites to learn. So you can review that and come back to this if you don't understand. This is the most easiest method to solve mesh analysis. By using matrices, you can solve any kind of equations, any three simultaneous equations or two simultaneous equations very easily. So I1 is delta 1 by delta, which is equal to 9 by 11. And now for going to I2, that is nothing but delta 2 by delta, which is minus 7 by 11. On solving these equations, we get I1 as minus 0.8181 ampere and I2 as 1.4545 ampere. So our V0 is nothing but, going back to the problem, is 6 times I2. V0 is nothing but 6 times I2. On using Ohm's law, V is equal to IR, we are gonna do it. So it is nothing but 6 times I2. And now we are gonna go to the next problem. So our answer is nothing but 8.272 volt. Okay, now moving on to the next problem. Next problem is, again we are gonna apply mesh analysis to find the I in the figure. I is over here, so we are gonna find it using mesh analysis. And here's how we are gonna go about it. So first we are gonna write down the circuit. Current over here is I1, I2 and I3, and for loop 1 we are writing the equations. Going through here, 6 is equal to 12 times I1. 6 is equal to 12 times I1. That 12 times I1 is nothing but 2 times I1 minus 2 times I2. So we are adding up this 2 times I1 and 10 times I1, and we are getting something called 12 times I1. And same I2 circuit flows over here, but in the opposite direction of I1. So we include a negative sign for that. So on simplifying that equation, we get 3 is equal to 6i1 minus i2. This is our equation 1. And now for loop 2, minus 8 is equal to, that is loop 2, minus 8 is equal to 2 times I1. So I1 flows through here, 2 times I1 plus 7 times I2. I2 flows over this 4, 5, 6 and 7. So 7 times I2. And minus I3 flows just through this 1 ohm resistor. So I3 is negative times because it is moving in a direction opposite to the I1. So for loop 2 we get something like minus 8. That is, minus 8 is equal to minus 2 times I1 plus 7 I2 minus I3. Now for loop 3. For loop 3 we simply get the equation minus 8. We have this voltage and plus 6, and then we have I3 over here 5, plus 6, so 6I3. But here I2 current also flows through this resistor, but in opposite direction of I3, so minus 1 times I2, so minus I2. On simplifying the equation for loop 3, we get something called 2 is equal to minus I2 plus 6 times I3. Now on putting 1, 2 and 3 in a matrix form, the same way, using the Kramer's rule, now we are going to solve something we are going to solve 3 simultaneous equations using the Kramer's rule. So here's how we go about it. We put all the 3 equations in a matrix form. Then we find out delta. Delta is nothing but the determinant of this matrix. So determinant of this matrix is going to be minus 234. Then our delta 2 is gonna be, that is replacing the second row with the constant matrix is gonna be 240, and delta 3, it is gonna be replacing the third row with the constant matrix, and then solving the equations we get something as minus 38. Now you may ask why we didn't find delta 1. The answer is within the question. We are going to find something at the node O, that is we are going to find the current at node O, that is at node O I plus I2 is equal to I3. If you look at this node, the figure in the question would be better. I and I2 are moving inside, which is nothing but equal to I3. So we need not even include I1 over here. So finding delta 1 would be a waste of time. So we are neglecting that. Our motive is to solve problems in a shorter time. So we neglect the delta 1 completely because there is no use of I1 over here. So on solving that, we get something as, so I is nothing but I3 minus I2. I3 minus I2 can be written as delta 3 by delta minus delta 2 by delta, which is nothing but delta 3 minus delta 2 whole upon delta. So on solving that, we get something as minus 38 minus 240 divided by minus 234. We get 1.188 ampere. And that's it. End of the slide. And hope you all would have understood something from this. Some knowledgeable stuff would have gotten into you, some productive stuff. So basically electronics is not a very difficult chapter. Once you understand everything in this particular subject, you can crack any kind of sum. It's just like mathematics. That is, you know the logic, you are gonna attack the sum in different ways. That is, the same sums, whatever we have solved here, can be done by using different methods. There are many methods called as nodal analysis, Thevenin circuits, Norton method, maximum power transfer. There are many methods in electronics which are very useful and which makes all these kind of problems easier. And it is up to us, like how we are gonna go about it. It depends on the problem, like how we are gonna go about it. And I thank you, my college. Yeah, and I thank you, my teacher, and all my friends for helping me do this video. And yeah, hope everyone find it useful. Thank you.